Alright, what's up guys? We're back with another video. So today we're going to be working on chemistry, oxidation and reduction practice work. Alright, so first to start off with what oxidation and reduction is, it's basically the loss or gain of electrons between elements or compounds in a reaction. So when something's being oxidized, it is losing electrons. And when something is being reduction or reduced, it is gaining electrons. So think of it this way. It's reducing its overall number because it's gaining a negative number. So it's being reduced. Electrons are negative. So that's what reduction is. Okay. So let's start with number one. So first, there's some rules that has to do with oxidation and reduction. So first things first, for pure elements, their oxidation number is always 0, and oxidation numbers usually go on the top of the element or whatever. So first we have 0 for sodium, and then for iron chloride. So since iron is with chlorine, which is a 1 minus, and there's 2 of them, that Fe is a 2 plus or plus 2. And then we go on to the other side, we have Na, which is a plus 1, and Cl, which is a minus 1. Because Na is plus 1 on the periodic table, because it's in group 1. And monatomic ions have the same oxidation number as their charge. But as we can see, minus 1, plus 1, it's good. And then Fe, since it's a pure element, this is going to be 0. All right, so now let's look at if this equation has any oxidation or reduction in it. All right, so we can see we have pure element, and then it changes its oxidation number to a positive 1. So right here, it shows it's being oxidized because it's lost electrons. So sodium is being oxidized. So sodium has been oxidized. Whereas the FeCl2, this one has been, or at least Fe has changed. So Cl has not changed. This oxidation number has stayed the same, negative 1. But iron, the 2 plus, has changed to a 0. So it's gained electrons. It's become more negative. So it's lost that positive and become a 0. So that means it's been reduced. So this iron chloride has been reduced. So sodium has been oxidized, whereas iron chloride has been reduced. And we would say that iron chloride has been reduced because iron is part of that whole entire thing right here. So we say iron chloride has been reduced. And that's what it is. And then the oxidation state, labeled each before and after the process. So the oxidation state, I have no idea what that is. I believe it's just the numbers, like the oxidation numbers on top. All I know is that sodium, since it's been oxidized, it is the reducing agent, which has caused the iron to be reduced. And since iron chloride has been reduced, it is the oxidation or the oxidizing agent. So that's question number 1. And that's what that basically is so far. So oxidized, Na has been oxidized, and FeCl2 has been reduced. So number 2 and 3, we're not going to do. But number 4, let's take a hand at it. So right here, we can see that it looks like a combustion, but it's not necessarily combustion because there's no metals in there. But I believe this is still a combustion. All right, let's just get into it. So hydrogen, pure element. So this is going to be a 0. O2 is going to be a 0. So these two are zeros. And then this one is going to have a change. Their numbers are going to go up and go down. So this one right here is definitely a redox reaction. Now we just have to find out which one is being reduced and which one is being oxidized. So oxygen is going to be a -2, whereas hydrogen would be a +1. So we have hydrogen losing an electron, meaning it's been oxidized, whereas oxygen has gained 2 electrons, so that means it's been reduced. So that's really simple, really easy. And if you follow some rules that have been handed out in class and we have on our notes, if you're in my chemistry class. And I'll show you the back of this paper, which also has some of the rules, or all of the rules. All right, copper, number 5. So copper is a 0 because it's a pure element right now. It's by itself, pure element. Hydrogen, it's a +1 when it's with, excuse me for my voice crack, when it's with any other elements. As we can see, +1 is with nitrate. So it's already been balanced because hydrogen plus nitrate is a neutral reaction. So O2 is always a -2. And since there's 3 of those and then there's 1 here, so let's think about it like this. -2 plus 3. So we're looking for the nitrogen. So we can do this, +1 or +1 plus x, right? Because n is equal to x. And so we're going to do a little bit of like algebraic expressions right here. -2 times 3, because oxygen has an oxidation number or charge of -2, O3, and there's 3 of them. So it's going to equal 0. So we'd say +1 plus x, right, -6 is equal to 0. 1 plus -6 is -5, right? So then we have x minus 5 equals 0. Move the 5 over, opposite operation, so x equals 5. So we would say that this nitrogen is a +5 in its charge, right? So nitrogen has a +5. So +1 for the hydrogen, +5 for the nitrogen, and -2 for the oxygen, as we can see, right? And if we go on the other side, we have another pure element, 0. So we already know this is a redox reaction. All of these are redox reactions. But what we're trying to find is which one is being oxidized and which one is being reduced. So as we can see, this copper, or the hydrogen right here, has lost an electron, or gained an electron. It has gained an electron because it goes from +1 to 0. So that means it gained a -1 to go to 0. So that means this one right here, we can already cancel out which one's been reduced and which one's been oxidized. Right here, this one's been reduced. And this right here is an acid, by the way. So I believe it's nitric acid, but don't hold me accountable for that. But all we know is that this has been reduced because this hydrogen has gained an electron. When you gain an electron, you've been reduced. All right, and then copper, as we can see right here, this is a -1 charge overall for nitrogen, and copper is probably going to have a +1 to accompany that because it's basically the same thing as that H. So the nitrogen's overall stuff did not change. The nitrate did not change overall, but the copper and the hydrogen did. Copper has lost an electron, becoming positive, so it's been oxidized. I hope this is making a little bit more sense between what oxidation and reduction is, and what things have been reduced or what has been oxidized. I'm sorry if this is a little bit blurry. It's just a little bit different. All right, so basically, when you gain electrons, you're reduced, and when you lose electrons, you're being oxidized. So overall, we're going to go to the rules on the back side to see what I'm talking about or whatever. All right, so rule number 1, the oxidation number of all elements is 0, including diatomic molecules like H2, N2, I2, those all 0. All free elements 0. So when it's by itself, it's 0. The oxidation number of monatomic ions like NH+, Ca2+, Al3+, or Cl- is equal to the charge of the ion. So if you see like Al with Cl- or Cl3, you would see something like Al like this. Let me write it at the bottom. AlCl3. Al3Cl3 right there. So we would know that anytime it's with a compound, it's going to be a 3+, usually, or most of the time. I believe it's all the time. But yeah, it's going to be a 3+. And since it's with this Cl, it's going to be a 1-, and hence there's 3 of them to balance it out, to make it neutral. But yeah, so that's rule number 2. Rule number 3 is the oxidation number of hydrogen is in most compounds is usually 1+, as we saw in the problems on the front, where hydrogen was 1+ when it's paired with something. The oxidation number of oxygen is in most compounds is usually 2-, except for peroxides like Na2O2 or H2O2. All right, and then number 5, the sum of oxidation numbers of all atoms in a particle must equal the apparent charge of the particle. So for an example on right here, it says in SO4 2-, each oxygen has an oxidation number of 2-, totaling -8, or 8- for SO4 to have a charge of -2- or 2-. The sulfur must have an oxidation number of 6+, because if the overall charge is a 2- and oxygen has a charge of -2 and there's 4 of them, that's -8. We would imply that sulfur has a charge of 6+ for us to have -8 plus 6 to give us a -2 charge overall. And that's only if there's an oxidation number overall for those compounds right there, or polyatomics. And rule number 6, group A elements have an oxidation number of 1+, group 2A, which is groups 1 and 2 on or columns 1 and 2 on the periodic table, going down from hydrogen down to, I believe, beryllium and other stuff like that, and from magnesium in them down. So that's what that means. So groups 1 and 2 have respectively charges of 1+ and 2+, and then aluminum always has an oxidation number of 3+, as stated in that second rule up there as well. So we can see that double down on some certain rules. So hopefully this video helps you guys, and I wasn't too convoluted on what I was saying, but please like and subscribe to support the channel. And yeah, thanks.